This is my presentation for MAC2233 Calculus for Business and Social Sciences. My business is called Just Eat It. It's a new company that is making edible cutlery to reduce the use of plastic and waste in the world. Our cutlery is made of organic corn and can be eaten or composted. We use the finest organic corn to produce durable, quality, and sustainable cutlery. Your meal is not over until you eat your fork. This ties to Sustainable Development Goal number 12, ensure sustainable consumption and production patterns. One of the goals' intention is to reduce waste. The challenge is there's a major problem in the United States and world with waste and plastics. According to NPR, every year the average American goes through more than 250 pounds of plastic waste, and much of that comes from packaging. According to BBC News, the world produces over 2 billion tons of municipal solid waste every year, enough to fill over 800,000 Olympic-sized swimming pools. Per head of population, the worst offenders are the U.S., as Americans produce 3 times the global average of waste, including plastic and food. Just Eat It has a mission to reduce the use of plastics in the United States and world, as well as reduce the amount of waste produced. Just Eat It's solution is to produce celery, forks, spoons, and knives made out of organic corn as a replacement for plastic cutlery. The goal is to reduce the use of plastic and waste in the world and the United States. This is our logo for Just Eat It and our advertisement, Just Eat It. You're not done with your meal until you eat your fork. The topic we're dealing with for this project is derivatives and elasticity of demand. Derivative is defined as the function's instantaneous rate of change at a certain point, and elasticity of demand is a measure of the responsiveness of consumers to a change in a product's cost. Applications of elasticity of demand are to find the best price, quantity demanded at the price, and the maximum revenue. I chose this topic, elasticity of demand, for Just Eat It to allow me to find the best price for each set of cutlery, the quantity demanded of cutlery sets, and the maximum revenue. This will help me to decide the best price to maximize revenue. Other applications of elasticity are cross-elasticity of demand, elasticity of supply, and income elasticity. My data is when I charge $1, the quantity demand is 1,000. When I charge $1.50, 830, $1.75, $6.25, $2, 550, $2.25, 460, $2.50, $3.50. Input is price, output is quantity. I have a scatter plot of my data, and when I did the regression of my data, I have the linear regression. Q for quantity, P for price equals negative 442.57p plus 1,447.21. The input is price and the output is quantity. The questions that I'll be asking are find the elasticity of demand, find the elasticity of demand at price 120, at price 235, finding the best price, and then finding the quantity and maximum revenue. I did a scatter plot of my data, and the linear regression goes right through the data. So first of all, to find the elasticity of demand, the formula is negative derivative of quantity demanded times price over quantity. So for this, it'd be negative times the derivative of quantity demanded, which is negative 442.57, times P over the quantity demanded function, negative 442.57p plus 1447.21. That leaves me with the elasticity demand function of 442.57p over negative 442.57p plus 1447.21. To find the elasticity demand at price 120, I plug $1.20 into that elasticity function and get 0.57. Since that result is less than 1, the price is inelastic at $1.20, and so the advice is to raise the price. But if I charge $2.35, plug that into the elasticity demand function, you get 2.55. Since the result is more than 1, it is elastic at $2.35, so the advice is to lower the price. So to find the best price, we set the elasticity demand function equal to 1, and then we solve for P, which leaves us with $1.64. So the best price per cutlery set is $1.64. To find the quantity demanded at that price, we take $1.64 and plug it into our original quantity function, quantity demanded function, and we get 722 cutlery sets. So to find the maximum revenue, we take the price, best price, $1.64, the quantity, 722 cutlery sets, multiply them, so our maximum revenue is $1,184.08. I learned many things in this project. I was able to find out that collecting data is important for business. The data can be used to get a regression function to estimate and predict the quantity changes based on the price. I learned that elasticity demand function can be used to find the best price and the quantity demanded at that price, and those two numbers can help find the maximum revenue. I learned that calculus is important to find the best price and to maximize revenue, and also that sustainability is important not only to the world but to businesses. Sustainability is important to consumers and is a responsibility to everyone, including businesses. Thank you so much.